All right, good day everyone. Welcome to Adventures in Old Code, episode 4. Looks like today we are looking at a program called Namegame. This should be good. Okay, here we go. I don't have any recollection what this is. Most of the time, I don't have any recollection what any of these are. Name game. Joey's name game. Well, that's an excellent comment there at the top. Okay, let's, as always, run this. Welcome to my name game. This is a game which sees how good you are. Type in your name and how good you think you are. I then pick a random number, and you have a 1 in whatever number you chose chance of being great in my eyes. Ready? Ready. Enter your name. Enter your name? Hello, great master. Okay. I suspect if my name was Fred, that wouldn't happen. How good 2 you think you are? Higher number the better. Well, as Fred, I think I'm good 8. Hey Fred, it looks like you're okay. Fred, you get an 8 out of 7.999999999 in my eyes. What? This time my name is Tom. 6. Oh, too bad. Tom, you are only 3 out of 5.999999999 in my eyes. Okay, I see what's happening. So the number that we enter is 6 in this case. I then take a random number between 1 and 6 and output it here. And so in this case, the random number chosen was 3. Now, why all those .99999s? I have no idea. We're going to find out. Okay, Joey's name game. So I have 3 subroutines: beginning, Joey, and crap. Wonderful. And I have a double floating point. So this is a number that contains many decimal points. This is probably the source of my .9999999, and I've called that good. Okay, we're clearing the screen, and then we're doing beginning. And this prints the message, ready. So not much going on here. Printing the text. Empty print lines. Prints with no quotations after it. It just means advance to the next line. Locate this place, 22, row 22, column 10, and print this message. Perfect. And yes, the do loop until in key string. So what happens is QBasic has this command. Well, not really a command. It's in key string. It basically, whenever you reference the in key string, it looks at the keyboard, sees if anything was input in that split second, and puts it into this string variable called in key string. So it's very impractical to use outside of a loop. So what I've done here is this is an empty do loop. So we do nothing. Do nothing until the in key string is not empty. So this will just wait, and when I push spacebar, then in key string becomes a space, and then this is no longer true, and it kicks out. So it's a way of pausing the screen until any key is pressed. I do end up using that a lot in a lot of the programs that I wrote. Okay, and then I clear the screen. Okay, then we go back to the main. Input, enter your name. And this is why I got the question mark. I probably didn't want the question mark. I probably wanted to do this, something like that, so that it would give me a colon and be nice like that, but I didn't. I used a semicolon, which is why I get the question mark. Okay, name equals UK string name. Talked about this last time. This uppercases your name. So if, put that in name string. If name string equals Joey, then run Joey. And Joey is print hello great master, you're the best of them all. End. This ends the program, just kills it right then and there. No more execution at all. So that's what happens when your name is Joey. Oh, here we go. Else, okay. So this is an if-else statement. I should mention that I probably, yes, I turned your name into uppercase because if I didn't, then if you typed Joey or Joey or Joey or Joey, you know, any of these variations here, these I would have to check explicitly. Did you type, you know, this? Did you type all lowercase? Did you type your name with only the capital O? I'm not sure why you'd want to do that, but the easy way to get around checking each different variation of the input was just to say, hey, whatever you input, just make it all uppercase, so I only have to check one case. So there we go. So if name is Joey, then run Joey. Else if. So if this isn't true, check if this is true. So apparently, if I type my name as so crap good, then something else is going to happen. Let's see. So crap good. You win. You're so crap good. Incorrect. Incorrect you're there, previous Joey, but that's okay. Okay. So I assume the same thing. Print you in, you're so crap good. Oh, I must have thought I was so funny. Unlike the other programs, this was probably just me having fun, because it doesn't look like a whole lot of things are happening here, although I say that now and then I see all this. Right. Okay, so input. How good do you think you are? Higher number, the better. So we're taking that number, we're putting it in the good variable. Then we're randomizing the timer. And so I'm creating one random number here. Usually I used to put these up at the top of my program as an inline function so I could just run it whenever I wanted to. But apparently in this program I only needed a single random number, and so I just did it here. Okay, so X percent must be why I'm getting the 0.9999999. That must be a double. That must be the double variable type. So when a variable is a string, you append it with a $sign. When a variable ends in a %, then that means it's a double. It's a double floating point number, so it contains lots of decimals. All right. So taking the random decimal value, multiplying it by your input number good, casting it to an integer and adding 1. Yes. Okay. If it actually was the good, so if you chose number 5, if my random number was 5, then it looks like you're okay. And here's a nice, I print your name, you get a whatever random number it was out of good in my eyes. Else, oh, too bad. Excellent. So good. Yeah, good is a double floating point value, but we input. So from that, I think if my name is Tom, I think I might be able to do a decimal value here. Okay, so it keeps the decimal value, but because it's a double floating point number, it doesn't play too nicely with actual integer values. And that's why all those 9s appear. You can also notice the large spaces between the numbers in Tom. You are only big space 4 out of big space 7. And that's because I was printing using the semicolon, which adds a space, and I also supplied a space. So that is why that is happening. So that's Joey's Name Game from October 26th, 1998. Stay tuned. We are very close to my very first complex program. It was written in October 1998, and I'm super pumped because I recall in that program there was one line that is sticking with me for the rest of my life, and I can't wait to get to it. All right, so thank you for joining me in Adventures in Old Code. This has been Joey's Name Game. All right, take care. Have a nice day. We'll see you next time. Hey there. Okay, this is an addition into episode 4. I made a huge mistake with my explanation of the % after a variable name. I said it was a double floating point number, and I think I was wrong. So let's find out if I was. I think that the % actually signifies an integer. Whoops. And so with that in mind, actually let's just start this. If I say x% equals 100.7, and I'm going to print x, 101. Do you see that? So what QBasic is going to do, and what all programming languages do, is you have different numeric types of variables. An integer is a number that does not have any decimal places. So if you assign it decimal places, most languages, including QBasic, will decide, well, you know what, I'm just going to figure that you want to not throw an error here, and so I'm just going to round what you've given me to the nearest whole number. And that's why my 100.7 rounds up to 101. I'm not sure what it does here. Okay, so it does do rounding, just like you learned in grade 4. This should be, oh, it does not round 100.5. What if 105.1? Okay. All right, so that's that. So let's go back to Namegame, because we were seeing some very strange behavior with those variables. So if I think I'm 7 good, notice how this 6.9999999, and whereas before it was all 9s, now it ends in 8. So let's go back down here. So X% is an integer. It doesn't have any decimals. Good is a double. And we know it's a double because up here we've declared it as a double. But I've inputted 7 as my double, and it prints out 6.99999. So let's try a few more experiments. We will say dim D as double. Input, let's do this. But let's do this. Use the comma this time. So D is a double, and then I'm going to print D, and we'll see what happens. 7, 6.999998. Okay. I'm not really sure what's happening here, and I honestly don't know if this happened using original hardware with the original QBasic. This being DOSBox, it might be changing things up here, but that is really, really unfortunate. Interesting. So 16 works fine. Let's clear the screen. 16 works fine. 10 works fine. I will bet, okay, has something to do with a 2-digit number. Once you get into the 2-digit number realm, you're fine. But once you stay in that single digit range, there's some bizarre things happening. Even though 7.99999 repeating is equivalent to 8, it's a mathematical identity, this doesn't look very nice. But that's just the peculiarities of perhaps QBasic, and perhaps it's just DOSBox doing funky things. I'm not sure. I don't have an original computer running QBasic to experiment on. Hopefully one day I will have one and I can run these things on native hardware once again. But for now we'll have to stick with the emulator and suffer through it. Ah, well. Okay, thanks. We'll see you next time. More adventures in old code.